In this problem, we need to find the limit as x approaches 2 of the absolute value of x minus 2 over x minus 2. And we've had problems like this before. It's almost the same thing over itself. I almost have x minus 2 over x minus 2. And when I have x minus 2 over x minus 2, I'm going to end up with 1. But sometimes I'm going to have a positive 1, and sometimes, because of these absolute values, I'm going to end up with a positive in the numerator, because this will always be positive, right? No matter what values I put in, I'm always going to have a positive numerator, but sometimes I'm going to have a negative denominator. So sometimes I will have a positive value in the numerator, and sometimes I will have a negative value in the denominator, which is going to give me a negative 1. So sometimes x minus 2, the absolute value, is exactly x minus 2, and sometimes it's the opposite of x minus 2. And that's because the opposite, when I end up with a negative number, the absolute values make it positive, okay? So when I've got that x minus 2 over x minus 2, I'm going to get a value of 1, and then I'll be finding the limit as x approaches 2 of 1. Or I'm going to have this one in the numerator, right? And when I've got that in the numerator, I'm going to end up with x minus 2, the opposite of x minus 2 over x minus 2 is negative 1. So we need to figure out what's happening here, and my guess is that 2 is going to be a very special place. So let me erase all this, because if I try to delete it, I think it's going to delete the picture with it. So let's talk about that domain. So what's happening here? Well, we know that x cannot equal 0. X cannot equal 2 because the denominator can't equal 0. So if I put a 2 in, 2 minus 2 is 0, not allowed to have 0 in the denominator. So any values that cause a 0 to be in the denominator are excluded from the domain. So x can't equal 2, and look at that. We need to find the limit as x approaches 2. So what's happening with this graph? I think it's best if we put values in. And rather than putting in values to the left of 0, it's all about what's happening to the left of 2 and to the right of 2. So if I put in a positive 1, in the numerator, I'm going to have the absolute value of 1 minus 2 over 1 minus 2. The absolute value of 1 minus 2 is the absolute value of negative 1. And the denominator is 1 minus 2, which is negative 1. The numerator becomes positive 1 over negative 1. So when I put a negative 1 in, I get a negative 1 out. When I put a 1 in, when I put a positive 1 in, when I put this 1 in, I get a negative 1 out. Okay, let's try this again with 0, because I think if we try this a couple of times, you're going to get the hang of it. You're going to see what's happening. So here's my x, and here's my absolute value of x minus 2 over x minus 2. Now, we put a negative 1 in. And when we put a negative 1 in, we got we put a positive 1 in. And when we put a positive 1 in, we got a negative 1 out. Now, if I put in a 0, let's go to the left a little bit more. If I put a 0 in, 0 minus 2 in the numerator, 0 minus 2. The absolute value of negative 2 is 2. And then if I put that 0 into the denominator, 0 minus 2 is negative 2. 2 over negative 2 is negative 1. So I put a 0 in, and I get negative 1 out. And if I were to put in a negative 1, if you were to put in a negative 1, I encourage you to use the table feature of your calculator. Use the table feature of your calculator if you need to. Or you can graph this and you can confirm that this is happening. When you put a negative 1 in, you're going to get a 3 in the numerator, and you're going to get a negative 3 in the denominator, and that's a negative 1. So when you put a negative 1 in, you're going to get a negative 1 out. So what's happening here is that. Now, if I put in 1.9 minus 2 over 1, the absolute value of 1.9 minus 2 over 1.9 minus 2, that's going to equal negative 1 as well. Because what's happening here is you've got that opposite of x minus 2. Okay? So you've got the opposite of x minus 2. When you put that 1.9 in, this is going to become negative. And then the absolute value is going to change that negative to a positive. So the absolute value, you're going to need that negative on the outside. If you drop the absolute value bars to come up with an equivalent statement, you'd have to take the opposite of this negative to make it positive. So all my values getting closer and closer to x equals 2 are going to have negative 1 outputs. Negative 1 outputs until you get to 2. Because you can't put 2 in, that's going to be an open circle. Now when we go to the right of 2, for instance, 3 minus 2. Now my absolute value, I don't need to make it positive. It's already positive. The absolute value of a positive is already positive. So in the numerator, I'm just going to have x minus 2. Whatever x is minus 2. So that's where I'm getting x minus 2 over x minus 2. And anything over itself is 1. So once again, when we put a 2 in, we can't. It's excluded, so it's an open circle. But no matter what value I put into the right of 2, I'm going to get a 1 out. Because I'm going to end up with the same number in the numerator as I have in the denominator. And they're both going to be positives. So now that we can see the graph of this function, we can see what's happening when we put a 1.9 in. And you can also do this algebraically. So let me take it from here. The left-hand side of 2, we're getting a negative 1 for our output. The right-hand side of positive 2, we're getting a positive 1. So the left does not equal the right. Therefore, the limit as x approaches 2 of the absolute value of x minus 2 over x minus 2 does not exist. Does not exist. But let's do this algebraically. Let's say we didn't know the graph. What I would do is I would say, what's the limit as x approaches 2 from the left? What's the limit as x approaches 2 from the right? So if I put in a 1.9, that would be the left. I'd have the absolute value of 1.9 minus 2 over 1.9 minus 2. And that's going to be 1/10 over negative 1/10. 1/10 over negative 1/10. And that's a negative 1. So this limit would be negative 1. On the right, I would put in maybe 2.1. So the absolute value of 2.1 minus 2 over 2.1 minus 2 would be positive 1/10 over positive 1/10, which is positive 1. And now we can say the limit from the left does not equal the limit from the right. Therefore, the limit does not exist.